Today we are going to discuss entropy and Gibbs free energy. Topic under discussion is entropy and Gibbs free energy. This chapter beta entropy and Gibbs free energy. Okay. So obviously topic has two parts. First part is entropy and the second part is Gibbs free energy. So we will start from entropy. Entropy, you need to know how to define entropy beta. Definition can be of 1 or 2 marks. So definition of entropy is number of possible arrangements, number of possible arrangement, arrangements of particles and their energy in a given system. Because this is how we need to define entropy. Okay. Number of possible arrangement of particles and their energy in a given system. For example, beta, if we have system means anything under observation, anything which is under observed will be system. So beta, let us say we talk about 3 states of matter. So what happens beta to the particles arrangement in solids? Solids may particles are close together. Okay. So if particle arrangement is like this, what about energy beta? Energy of particles is less because particles will move less. Kinetic energy will be less. So solid may particles or molecules have less energy because their arrangement is in this way that more energy is not possible. Okay. What happens beta to the arrangement of particles in liquid? This is liquid state beta. This is liquid state. में और गैस में पार्टिकल अरेंजमेंट्स में फर्क है बेटा गैस इज लाइक दिस तो किस केस में एनर्जी इज ग्रेटर गैस में किस केस में एनर्जी इज लेसर इन विच स्टेट पार्टिकल्स आर मोर ऑर्गेनाइज्ड मोर ऑर्डर्ड मोर सॉलिड में मोर ऑर्डर्ड है पार्टिकल्स पार्टिकल्स आर मोर ऑर्डर्ड ओके तो बेटा जितने ज्यादा ऑर्डर्ड होंगे पार्टिकल्स एंट्रोपी विल बी लेस ओके so we would say a solid में entropy is less, randomness is less. Okay, so entropy can be related to randomness. More ordered का मतलब है less randomness. Solid में randomness is less. So less randomness means less entropy. Gas में बेटा less ordered हैं particles. What they are? They are less ordered and more randomness. So more randomness means greater entropy. Okay. More randomness means greater entropy. Any confusion, beta? So entropy can be estimated from randomness of particles as well. Okay. Entropy can be a measure, of randomness, can be a measure of randomness of particles. Randomness of particles in a system. Got it, beta? Okay. Beta, we follow these rules. Rules of first rule is if we compare solid, liquid and gas, so solid, liquid and gas में what do you think beta कि which substance has more entropy, which substance has less entropy?
Gas.
Greater entropy is there for gas. Okay, greater entropy for gas. And beta, solid has less entropy or less randomness. This is first rule beta we will follow. And second rule we will follow कि if state symbol is same, क्या बेटा, if state symbol is same, तो फिर state symbol is same, तो बेटा उस केस में फिर एंट्रोपी इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर। अगर स्टेट सिंबल सेम है तो एंट्रोपी इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर। ग्रेटर एंट्रोपी मींस greater temperature means greater entropy and vice versa. Suppose we have water in two containers. Okay, we have water over here. We have water over here. So one container में temperature is 25 degree Celsius, the other container में temperature is 40 degree Celsius. You think कि both waters, और दोनों let's say 1 mole water है, amount of water भी same है, 1 mole water here and 1 mole water here, state symbol भी same है, amount भी same है, temperature different है. You think कि randomness same होगी दोनों में? किस केस में randomness is? So 40 degrees पे we would say greater entropy. The reason is kinetic energy of particles is more. High temperature पे kinetic energy of particles will be more. Okay, greater kinetic energy of particles. Got it? So जितना ज्यादा टेम्परेचर होगा, अगर स्टेट सिंबल सेम है बेटा, तो फिर हम टेम्परेचर को देखेंगे। जितना ज्यादा टेम्परेचर होगा उतना एंट्रोपी ज्यादा होगी, जितना टेम्परेचर कम होगा उतनी एंट्रोपी कम होगी। दिस इज द सेकंड थिंग बेटा। क्या बेटा? नेक्स्ट कॉन्सेप्ट इज व्हाट? एंट्रोपी ऑफ सब्सटेंस। हर सब्सटेंस की कोई ना कोई एंट्रोपी वैल्यू होगी, that is measured and reported in chemistry literature. You are not supposed to memorize that entropy value, okay? Every substance has its own entropy value. Entropy is represented with S. Entropy is represented with S. We place it, we show it as S naught. This naught is for standard conditions, okay? What this theta represents, beta? This theta represents standard conditions. Like we would say standard entropy. Standard entropy means entropy of a substance under standard conditions. Okay, so this naught is for standard conditions. What conditions are standard, beta? You know, what conditions will be standard? Temperature, what is standard temperature? 298 Kelvin or 25 degrees Celsius. What is standard pressure, beta? 180. Okay, and concentration is 1 mole per dm cube. Okay, so these are standard conditions, 1 mole per dm cube. So entropy of a substance under measured under standard condition will be referred as standard entropy. So standard entropy, but the entropy unit is joule per Kelvin per mole. What is the unit, beta? Joule per Kelvin per mole is the unit of entropy. So standard entropy of these substances are given like this. You are not supposed to memorize these values. Okay. इन वैल्यूज को आपने मेमोराइज नहीं करना। सो दिस वन इज +22, दिस वन इज +286 एंड दिस वन इज +394। बेटा, व्हाट डिफरेंस यू कैन सी इन द एंट्रोपी वैल्यूज एंड व्हाई? हाँ बेटा, व्हाट, which substance has lesser entropy? Why? Because this is solid. These values are actually referring to the rule we decided that solid will have less randomness or gas will have more randomness. So every substance will have its own entropy value. You are not supposed to memorize those values, okay? बस हर substance की अपनी एक entropy value है. Entropy can only be zero at 0 Kelvin. Entropy can only be zero at 0 Kelvin. Why, beta? Why entropy is 0 at 0 Kelvin? Shabash, very good, beta. Kinetic energy of particles becomes 0 at 0 Kelvin. Kinetic energy of particles become 0 at 0 Kelvin. So that is why the randomness vanishes. There's no randomness at 0 Kelvin because molecules will not move at all at 0 Kelvin. So only at 0 Kelvin, the randomness will be 0. Otherwise, there will be entropy value for rest of the temperatures. Okay. What is melting point of ice? Melting point of ice 0 डिग्री सेल्सियस तो केल्विन में कितना होगा 273 केल्विन. And what is boiling point of water? So केल्विन में कितना होगा 373 केल्विन होगा. Okay. Suppose if you have to make a graph between entropy and temperature. So but I'm taking temperature here on x-axis and this temperature is in Kelvin. So we will start from 0 Kelvin beta. This is 0 Kelvin. So let's say somewhere here we have 273 Kelvin. And somewhere here we have 373 Kelvin. Just look beta. And here I'm writing entropy or randomness. So randomness will be 0 at 0 Kelvin. We just decided. At 0 Kelvin, the randomness will be 0. But what happens when you increase temperature? What happens to entropy? Entropy increases when you increase temperature up till this point. But what happened? This is what it is, beta. This is melting point of ice. This is beta entropy of ice we are talking about. Okay. So what happens at 273 Kelvin? Ice melts. So ice converts into liquid water. So water has more randomness than solid. Okay, liquid has more randomness than solid. So why there is abrupt change in entropy? Because state is changing. Okay, state is changing at melting point. What happens जब water को आप heat करोगे तो water का randomness भी increase करेगा until you reach the boiling point. What is 373? Which this is boiling point. The boiling point of what happens? Liquid goes to gas. Liquid goes to gas. So again, an abrupt change in entropy is happening here, and then gas को जब आप heat करोगे तो randomness will further increase. Got the idea, beta? Beta, why this vertical line is bigger than this vertical line? Because there's more entropy change from liquid to gas than solid to liquid. Got the idea of the graph? Because gas may molecules are much away from each other, there's more randomness. Liquid may molecules are not that far away. Solid may closely packed होते हैं. Okay. Beta, this uh, okay. Yes. Entropy Entropy change is the next concept. Entropy change. Entropy change is represented with delta S naught, or this is standard entropy change. Okay? So standard entropy change is studied for a reaction, for a chemical or physical reaction, okay? For a chemical or physical process, for a chemical reaction or for a physical process. Visibility हम चेक करते हैं गिब्स फ्री एनर्जी से, नॉट विद एंट्रोपी चेंज. ओके. अच्छा बेटा, जो एंट्रोपी चेंज है, now there are two signs for entropy change. Entropy change can be positive, entropy change can be negative. When entropy change is positive, when it is negative, if randomness is increasing, what beta? If randomness is increasing, then entropy change will be taken as positive. और randomness increasing का मतलब है कि products has more entropy than reactants. Products has more entropy than reactants. In this case, randomness will increase. Okay. Entropy change will be negative if, बेटा बताएं. हाँ, yes, less. हाँ, if randomness is decreasing, okay. अगर randomness decrease हो रही है, या if reactants has greater entropy, reactants has greater entropy, then products. So then beta, delta S will be negative. Okay. So for example, if I give you an equation like this beta, so you decide कि इसका delta S will be positive or negative. Entropy change is positive. Why beta? What reason you will say? You will say 1 mole gas is produced. 1 mole gas is produced from 1 mole solid, from solid. And gas has more entropy than solid. Gas has more entropy than solid. Right, beta? So various examples, beta, can be asked like if this is second example to decide, beta, the entropy change is positive or negative for this example or not. What you will say, beta? Delta S is negative. And what reason you will say, beta? 2 mole gas, 2 mole gas converted to 1 mole solid, 1 mole solid. And solid has less entropy. Gas has more entropy. Gas has more entropy. Gas has more entropy than solid. Right? Better just how about this example? Carbon monoxide gas plus 2H2 gas goes to CH3 OH liquid. Jupiter. How you decide? Decreasing. So entropy change for this reaction is negative because 3 moles gas converting to 1 mole liquid. Liquid has less entropy than gas. But what about this one? What you say? Entropy change is positive or negative? Entropy change is negative. Why it is negative? 3 mole gas converting to 2 mole gas. So the moles of the gas are decreasing. Okay. Why beta? Moles of gas are decreasing. And whenever entropy is decreasing, then delta S will be negative. Acha. What about physical processes? Now, this is physical process. Sodium chloride is solid. When it is dissolved in water, aqueous means water as solvent. So you get sodium chloride aqueous. So what happens to randomness? Is it increasing or decreasing? It is increasing. How you claim kid randomness is increasing? Because this is solid now. So there's no more solid on the right hand side. Look, this is aqueous now. Can aqueous be referred to as aqueous is liquid, yes. So entropy change is negative in this case. Sorry, positive in this case. Positive in this case because solid has less randomness than liquid. Solid has less entropy than liquid. Any confusion here, beta? Any confusion? Beta, what about these physical processes? Suppose if I say melting, what happens in melting? Solid goes to liquid. So delta S is positive or negative? Delta S is positive. Achha, beta, what about condensation? What happens in condensation? Vapors goes to liquid. So randomness in this case is decreasing. So whenever randomness is decreasing, we will say it as negative. What about sublimation? Positive. What happens in sublimation? Solid goes to gas. So randomness in this case is increase. Whenever randomness increase, delta S will be taken as positive. This is the concept, okay? Got it? Okay. Now with our calculation of entropy change. Calculation of entropy change of reaction. So the entropy change of reaction is calculated with the expression. आप लोगों ने entropy change of reaction is calculate करना है इस expression से products minus reactants. Okay, products minus reactants. Just use this expression. For example, if they give you an equation, this is their equation, beta, carbon dioxide plus 2H2O. And the entropy, beta, what is the unit of entropy? Joule per Kelvin per mole. Okay. So you are not supposed to memorize the values. Values will be given. So let's say the entropy of CH4 is minus, sorry, cannot be minus 430. मैं बता हाँ yes. बेटा ये supposed values हैं, okay? 394. Oxygen is 205. And carbon dioxide हो गया H2O is 286, 186. These are supposed values, okay? May not be the actual values. I took these values just for the practice. So, beta, how to plug the values? CH4 की entropy is how much? 430. Oxygen की is 2 into 205, right? Carbon dioxide is how much? 394. What about water? 2 into 186. Got it? So entropy change of reaction will be equal to what? Products minus reactants. So products में 394 है plus 2 into 186 है. Okay, this is product beta. Minus reactant is 430 plus 2 into 205. Just someone should solve it. Take out the final answer. Final answer will be in joule per Kelvin per mole. This is how you calculate entropy change of reaction. This is how we calculate entropy change of reaction. Minus 74 is the entropy. And this is minus because the moles of the gas are decreasing. How many moles of gas you have on left hand side? 3 mole gas you have on left hand side. Okay. Or right hand side you have 1 mole gas. So randomness is decreasing. That is why the entropy change is negative at the. Got the idea, beta? And beta, let us discuss some. What they said, describe and explain what happens to the entropy. When temperatures increase, entropy increases. Why? Kinetic energy of the particle increases. Just quickly tell me the science, beta. What science you will use? This one is negative. This one is negative. Beta, why this is negative? Liquid, there's no liquid on right hand side. Okay, solid has less randomness. What about this one? This is positive. This is positive because of this gas. Explain why entropy change for the first process is negative.
Entropy of gas is greater than the entropy of solid.
And moles of gas are decreasing. Right? That is the reason. Now, beta, what about the next part? What they say? You have to calculate entropy change of reaction. How you need to do? 192 is the entropy of nitrogen. 3 into 131, and this is 2 into 193, okay? What formula you will use? Products minus reactants, which happens to be 2 into 193 minus 192 plus 3 into 131. What answer you got, beta? Minus 199. So what does this minus sign represent? Randomness is increasing. And why randomness is decreasing? Because you have 4 mole gas on left hand side and you have 2 mole gas on the right hand side. So randomness is decreasing, okay? So this is how beta you need to calculate. Gibbs free energy, we can discuss in next class. But right now, let me check if we have beta how to go for this one. Calculate the standard entropy of chlorine. Standard entropy of, I will take 2x, and entropy of silicon is 18.7, and entropy of silicon tetrachloride is 239. Okay, so entropy change is equal to products minus reactants. Entropy change is given, that happens to be minus 2 to 5.7. Product is 239 minus reactant is 18.7 plus 2x. Would you be able to solve it for x? And x is your answer. And that is what we have for today.